SOLIDWORKS provides unique capabilities that make designing the most complex plastic parts easy and productive. Let's take a closer look at Now's Head to see how Aldebaran Robotics used SOLIDWORKS to not only design a plastic casing that addresses their numerous requirements, but also fits over 150 components. We'll begin by showing an exploded view of the head where we can see all the individual parts and the challenge of creating the right casing. From analysis tools like the interference detection tool to intuitive fastening features that automate the creation of standard plastics features, modeling plastic parts has never been easier. In addition, designers can use SOLIDWORKS plastics to predict and avoid manufacturing defects during the earlier stage of the plastic part design. This can eliminate costly mold rework, reduce time to market, and improve part quality. We'll demonstrate this using the Now model as an example. SOLIDWORKS Plastics includes a powerful and fast mesher, an extended material database of more than 5,000 commonly used commercial-grade plastics, and various processing parameters that can be specified, such as the injection molding machine size or the melt and mold temperature. After running the analysis, we can see here that the back of robot's head is not completely filled. This short-shot phenomenon is due to the melted plastic solidifying before reaching the end of the cavity. The different result plots, like the frozen layer fraction plot, are invaluable in identifying the cause of the problem. In this case, it can be easily solved by changing the geometry of the part and increasing the size of the ribs, or by modifying the injection location. Since SOLIDWORKS Plastics is fully embedded inside of SOLIDWORKS, changes can be made very easily and are quickly taken into account. We can now see the part being filled completely. Animating the fill time plot shows exactly how the melted plastic is injected inside the cavity and provides in-depth insight into the injection molding process. It also helps to diagnose potential molding, cosmetic, or structural problems. The air bubble trapped as well as the problematic weld and meld lines can be instantly visualized. You can also review the volume shrinkage distribution to efficiently determine the optimum packing parameters and therefore reduce sink marks defects, or the cooling time plot to improve cycle times. Once the part is filling properly, we can move on to designing and analyzing the family mold layout that will be used to produce the head of the robot. This guarantees that the mating plastic components have the same mechanical properties, color, and appearance. However, to ensure the quality of the parts, control shear heating, and minimize stress levels, the mold cavities need to be filled simultaneously. SOLIDWORKS Plastics lets you model, adjust, and automatically balance the runners, sprues, and gates to rapidly optimize the feed system of multi-cavity molds. Thanks to SOLIDWORKS and SOLIDWORKS Plastics, designers and engineers can create problem-free plastic parts and let their imaginations run wild as they design the future of robotics.